Problem number 5 of continuous random variable title is here. If the density function of a continuous random variable x is given by f of x equal to ax, where 0 less than or equal to x less than or equal to 1, it is a when 1 less than or equal to x less than or equal to 2, it is 3a minus ax when 2 less than or equal to x less than or equal to 3, and it is 0 elsewhere. Question number 1, subdivision 1 is find the value of a. Question number 2, find the CDF of x, and the last subdivision 3 is if x1, x2, x3 are three independent observations of x, what is the probability that exactly one of these three is greater than 1.5? Actually, the problem has a PDF with some unknown constant a, so we should find it first and then CDF. The last portion is having some conditions. We have to find the probability value with specific conditions. Now the first part, before entering to the first part, the problem actually uh, with the PDF which is defined in the interval 0 to 3, and it is splitted into three parts. One is 0 to 1 and the next one 1 to 2 and the last one is 2 to 3. Remaining portion the function is 0. Here we draw a real line and that is written in each of the sector. To find A is the first part of the question. For that we use property of PDF, which is integrating f of x, we get 1. So here the region is Rx, means the region, it is 0 to 3, and 0 3 is splitted as 0 to 1, 1 to 2, and 2 to 3. Each of the portion of the integral, we have to enter the integrand as ax, a, and then 3a minus ax. After integrating, we'll get ax as ax square by 2, corresponding limit is 0 to 1. Then a becomes ax from limit 1 to 2. 3a minus ax becomes 3ax minus ax square by 2 from the limit 2 to 3. So with this respective limits, right side is 1, evaluating we get a as 1. The next portion of the question is second subdivision. We have to find CDF. For finding CDF, we have to take x value lying in which part. That's the first part question. It may be either 0 to 3 interval or to the left or right side. So x less than 0, uh, that is left to the interval. X is less than 0 is the first case. But for this case, yeah, obviously f of x is 0, the total CDF also becomes 0. So f of x is original definition is probability of x less than or equal to x. Anyhow, f of x 0 implies the value here is 0. Now when we take x value as lying between 0 to 3 and particularly 0 to 1 case, so here according to the definition of CDF, we can write it as integral 0 to x f of x dx, which is ax dx, integral 0 to x ax dx. After integrating and applying, we get x squared by 4, because integration gives us x squared by 4. And if the upper limit x is applied for x itself, x for x, so didn't change anything, and lower limit 0 will give you 0. So final function is x squared by 4. The next part is when x is lying between 1 to 2, if x is lying in this gap 1 to 2, we cannot write small f as a single entry. So we have to split the integral into 0 to 1 part and 1 to x part. And each of the respective portion will be replaced by the respective integral. Integrand here is ax and the next one is a. There is no need to write even a each time, because already we obtained the value of a can be replaced by 1 by 2. So after processing, we'll get it as x by 2 minus 1 by 4 for x case in 1 to 2. The next one is when x is lying between 2 to 3. Here also same discussion, capital F of x equal to 0 to x f of x dx. But Instead writing f of x as a single function, there is no possibility here for that. So split the integral as three parts: one 0 to 1, another one is 1 to 2, the last one is 2 to x. So after doing the same procedure with the respective integrals, we get the final function as 3x by 2 minus x square by 4 minus pi by 4 for capital F of x in the interval x 2 to 3. The last case is x greater than 3. Under this case, we can write 0 to x f of x dx for capital F. And of course, 0 to 3, it becomes 0 to 3 because above 3 function value is 0. Therefore, we can restrict the integral 0 to 3 f of x dx, and f is a PDF and integral value is 1 now. Third subdivision of the question is to find probability value of x greater than 1.5. That is integral 1.5 to 3 f of x dx. It is splitted as 1.5 to 2 and 2 to 3. So evaluating, we get the answer as 1 by 2. Now, original question is there are three observations, and out of which one exactly satisfies this probability condition. So we have to find the probability as the final value. Now the term we obtained probability of x greater than 1.5 is taken as success probability, which is simply denoted as small p, and q is failure probability. The value is 1 minus p, which is also 1 by 2. Number of observations, obviously it is 3. They are giving it as 3 in the third subdivision question. Now Bernoulli's theorem, according to Bernoulli's theorem, formula is NCR p power r q power n minus r. So n r p q, all the entries are substituted. So for exactly one value should be greater than 1.5, probability value is calculated by this formula. So the answer is 3 by 8 here.